Hey guys, who are we missing? Can you guys hear me?
Yep.
So where is Alexis?
She was having issues getting in.
Oh, there she is.
Oh, there she is.
Just appeared. All right, today we're going to be talking about pull and hodl. And so I'm going to turn it over to Alexis. She's presumably going to share her screen with us and take it away.
All right, just a second. Okay. Thanks. Can everybody see my screen?
Yep.
Okay, cool. All right, guys, I'm here to present this paper to you, or rather, you're here to present it to me. So hang on. How do I get to the next slide? Found it. So I wanted to start out with like some of the theoretical background of the paper, Trivers and Emlen and Oring. So can anybody tell me kind of what Trivers, his work in 1972 was all about, kind of the ideas we discussed in class, if anybody remembers?
I know the paper, like Pull and Hodl or whatever, talked about parental investment and how that affected like mating competition between the sexes.
Yeah, that's right. So essentially, it was kind of all about this idea that females generally are the sex that invests more in their offspring and thus can be choosy about males trying to get better resources and genes. And then in turn, males are investing more in competing for access to a limited supply of females. Does anyone have anything to add to that? No. All right. Well,
Come on, guys.
You mean just to like background in general, or to like that specific study?
I'm looking for like the tie-in with Emlen and Oring about a limited sex.
Oh yeah, I mean just that. I mean, there's the parental investment theory that they talk about, which just argues that when one sex becomes a limiting factor, which could be due to parental investment, oftentimes being the female, the result is that there's increased intersexual competition among members of the opposite sex, which would be males.
Yes. Thank you, Kennedy.
Mm-hmm.
Okay, so that covers some of the theories that kind of inspired this research. Now I was hoping to get some definitions and terms out of the way just to make sure that we all understand what's going on in the paper. So can anyone give me a working definition of PRR, or potential reproductive rate?
It's like the maximum number of offspring that a parent can produce per unit of given time.
Yes, that is correct. And can someone other than Kennedy or Logan explain how potential reproductive rate is related to parental investment?
More parental investment leads to a lower PRR because the time that you could be investing in a greater reproductive rate is being taken away as a result of increased parental investment.
Yes. So the sex of the parent that is investing more in producing and caring for offspring has a lower potential reproductive rate because of that time that they're spending investing in those offspring. So then we have an inverse relationship. Now, can someone else explain to me what this idea of time out is and how that's related to the potential reproductive rate? Excuse me.
Timeout is how much time the male or female would spend doing things that is not mating. So like for the females, it would be the time she spends raising the tadpoles or her young.
And so if she's spending more, if the time out that a parent is spending caring for young is increasing, then what happens to the potential reproductive rate?
If the timeout is increasing, then this goes down.
Again, we have an inverse relationship. And then the last term that I wanted to make sure everyone understood was this operational sex ratio. Does anybody have a definition for that they want to share?
That's a ratio between like females and males in a like environment. Like the ratio.
Yeah, so it's not exactly the ratio of like the straight number of males to the number of females.
Isn't it? Oh, my bad. Isn't it like how they mate or like when they're ready to mate?
Yeah, it's the number of males and females who are ready to mate at a given time. So you guys can see how potential reproductive rate might affect the operational sex ratio, because if one sex has a high potential reproductive rate, there are more of those sex that are ready to mate at a given time than the sex that's spending more time out, if you will, and investing more in producing and caring for offspring. All
Just
right.
a note here. In other contexts, operational sex ratio can also refer to the number of individuals who actually end up mating, whether they are not mating because they're occupied with other activities, or it may be that they're not mating because of things like male-male competition and one or a few males are getting all of the matings. So the reason that this becomes important is when you start thinking about the evolution of this system, if the operational sex ratio is really skewed such that only a few males are doing the bulk of the mating, you actually have a much smaller population size than you would if all males were mating equally. And because most models of evolutionary change depend upon some estimate of what the population size is, getting the sex ratio wrong gives you the wrong answer ultimately. So a lot of times people, when they study these things, they just take the sex ratio of the population. We have this many males, we have this many females, but if big chunks of either the males or the females are not getting the opportunity to mate, then that observed sex ratio is different than the actual sex ratio, which is called the operational sex ratio.
That was the scenario that we talked about with the giant, ugly seals. What? No. The fighting guys in the lek. What were those?
The elephant seals.
Elephant seals. Aye.
Oh, I'm muted. Elephant seals, yes.
Okay, cool. Okay, so that's some background information about, just terms and background theories and whatnot. Now let's get some information about the frogs that they were actually studying. D. Pumilio, strawberry poison dart frogs. Does anyone remember where these frogs typically are found?
Yeah, Nicaragua to Panama along the Atlantic coast.
And then for this study, where was the population that they were looking at? Where was it located?
Costa Rica.
Right now.
Okay, and then if someone else could tell me a little bit about the differences between males and females as far as their parental investment goes, like what kind of roles do they play in parenting offspring? How do eggs form tadpoles, and how parents care for them along the way? So, for instance, the mother just laid her eggs. Now what?
The the dad goes through and hydrates the eggs, which takes like 10 minutes. And then after they hatch, the mother takes them to like a pond or a water area to raise them because they're tadpoles.
See, essentially that was like the idea that I got at first, but actually Paul let me know that bromeliads are really a plant. You can look them up. I probably should have included a picture. Well, can I go to the internet? No, maybe.
Go to the internet if you need to.
I'm gonna go to the internet. Look, see, it's in my recent history.
Do you have it sharing the PowerPoint, or do you have it sharing your desktop?
Oh,
Because I'm still seeing a frog.
okay, hang on. So should I hit stop share and then reshare?
Sure.
Yeah, and then select your internet browser.
Okay.
Or just select your whole desktop and then whatever you're looking at, we're looking at.
So can you see that?
Yep.
So if you see, you know, they're kind of flowers, and within the flower, there's like a little pocket of water. You guys see that in the axil of the leaf?
The one down below is also good to look at. Yeah,
This
that one. That area in the center will be filled with water.
Yeah. So that's where the eggs are laid, and the mother takes the tadpoles from one bromeliad to the next. She kind of stops by and they swim up on her back and adhere to her back. Where's the PowerPoint? Okay. And she'll transport them from bromeliad to bromeliad, making sure that they have water. And another fun fact that I got from Paul is that as the males are hydrating their eggs, it's actually them sucking up water into their urinary bladder and essentially peeing on the eggs, which isn't exactly what I thought of when I read the paper, but you know, good for you guys to know. Let's see. Does anyone else have any other background information about these frogs that they had written down? Or any questions?
The females' throats are red and the males' throats are gray or black.
Yes, and that's how they identified males versus females while they were making their observations.
Is there anything else related to investment by either male or female?
I know the answer to this question, but do you guys know the answer to this question?
It's in the paper.
So for instance, like as a female is investing all this time and energy into all of her different roles as a parent, what is a male investing a lot of time and energy into doing?
I mean, calling takes a lot of energy in general, but also like defending territory, to have that space for calling activity and for meeting activity.
Right.
Those are costly.
Yeah, that's what I was kind of looking for, advertisement calls by males, and they note that those are high intensity calls, and that's how the male frogs are trying to attract the females. So it kind of goes along with Triber's idea that females are spending time investing in offspring and males are investing their time and energy into trying to attract females.
I was actually thinking of something, and maybe you said it and I missed it, but having to do with female investment.
I know. Okay. So do you guys remember after, you know, the tadpoles have hatched, how the mother kind of supplies nutrients to the tadpoles?
This is what I was looking for.
They're fed with unfertilized eggs.
Yeah.
So
So
she
she'll,
has to basically produce more eggs to feed the ones that are hatched.
right. And she'll stop by and feed them their unfertilized eggs from time to time. And that kind of goes along with time out, which we'll talk about later, but anything else?
Yeah, as we progress through this, the authors of this paper are paying a lot of attention to cost in terms of time. But as you think about this paper, think about costs in other terms. And this idea of females feeding their offspring unfertilized eggs, that basically illustrates another kind of cost in addition to time, which they didn't actually quantify in this case.
Aye, aye. Okay, so now we'll kind of move on to their big overarching question. So this is in the paragraph in the paper above the hypotheses. Does anybody remember what that question was? Jasmine?
Who's Jasmine?
Oh, I'm sorry. I just got a
Who
text.
is Jasmine?
Sorry. I have 6 electronics open. Go on. Let's see. Wait, where am I? Okay. I'm sorry. This is going some type of way. Anybody? Big question? No.
You said it was in the paragraph above the hypothesis?
Yeah, so on page 216, column 1, midway through the split paragraph.
Okay. Is it just like analyzing and understanding the mating system in relation to the PRR and the OSR?
Yes, exactly. Thank you, Haley.
Yeah, and it's not expressed in the paper as a question, but that's the question.
That is, yes. Okay. So yeah, it's just figuring out how the potential reproductive rate of males and females and the overall operational sex ratio is influencing the mating system of these frogs. And then
what's interesting to me is that at the end of that paragraph, they say the social behavior of Dendrobates pomelio seems particularly interesting because males are territorial and their parental care is minimal, whereas females perform most duties associated with care of offspring, which strikes me as the least interesting thing about the system because that's the situation that occurs in the vast majority of cases.
Right. Okay. So now that you guys have the paper open and you're on that page, can somebody give me a rundown of the hypotheses?
Well, because we know that females perform most of the parental care duties, their parental investment will be higher, meaning that their time out will also be higher than males. And therefore, due to that inverse relationship, they'll have the lower PRR and become the limited sex.
Right. And then because of that low PRR, what is the next hypothesis?
Females are going to be more choosy.
Yeah. And then in turn, that choosiness of females will affect what?
Male competition.
Yes. So male mating success. So females have a lower potential reproductive rate, which means they're going to be choosy, and that choosiness will then lead to male-male competition. And in some cases, you know, the most highly qualified male, based on certain traits, will win more mates than other males, which we'll talk about the traits later. Ooh, and I gave it away. The last one just had to do with this male territorial behavior and the fact that it relates to competition for females. Does anybody have any questions about any of those?
Nope.
Thank you, Haley. Okay, now I want to talk about the methods up until the point of data analysis. So kind of how was the study area set up? What were they measuring? How did they observe the frogs, etc.? Luke? Caleb?
Yeah. They they captured the frogs and they deciphered whether they were males or females by looking at their throat colors, and then they found the time where calling and mating activity was the highest, and they found that to be from 7 a.m. to noon, and used that time over a certain amount of days to record the courtship and mating and calling variations within that time.
Yeah, that's pretty good. I would make the addendum that I think the time that was highest was from 8 to 11, so they kind of went an hour on either end just to make sure that they were picking up all of the best time to make observations. Did anybody remember kind of how the study area was divided?
Into 1 by 1 meter quadrants.
Right, with these overhead nylon strips, and I kind of picture in my head that they're hanging from trees in squares so that the researchers weren't stepping on them and they weren't getting messed up. So yeah, the space bar on my computer doesn't work. Okay, so they have the study area divided into 2 quadrants, and then they're capturing the frogs, clipping their toes, taking basic measurements of them. And then I listed all of these different things that they recorded. I think that they were very careful in their observations and really wrote down everything they could, position in the study hour, in the study area, perch height, courtships, matings, all of the young development, etc. But I wanted to make sure you guys understood the difference between some of these variables. So does somebody want to explain to me the difference between a courtship and a mating?
A courtship is just the interaction where a female approaches and follows that male. But the mating is when that results in oviposition in a clutch.
Right. And then someone else, the difference between mating success and reproductive success of males?
Mating success was measured by how many mates the male obtained, and reproductive success was measured by the total hatched tadpoles of each male.
Correct. Okay, yes. So now they're doing these observations every day, recording all these variables, and then they have a lot of data, and I have kind of split this up into a data analysis followed by results section. So we'll kind of talk about each piece one at a time. And the first one that I wanted to talk about was population density. So can someone tell me how they measured population density of males and females?
The Peterson method, which is from another study. I don't really know what that is, but is that?
Yeah, so I didn't have a great idea about the Peterson method either. Does anybody else know about the Peterson method, or should I explain?
I know about it.
Paul knows, okay. Anybody else? No?
Not really.
Okay, cool. Not, well, you know what I mean. So the Peterson method is, from my understanding, based on what I spoke with Paul and then a little bit of reading that I did, is essentially a method whereby the researchers would go out and capture a set number of frogs during a certain time period, and they would mark all of the frogs that they captured as these are captured frogs, and then let them go. And then they would come back at a later time and capture another set of frogs, and the number of frogs that had been marked in the previous kind of attempt here would then be added to this pile of new captured frogs, and it would tell them about how many frogs they had accounted for in the population. So if they picked up 10 frogs on the first day and marked all 10 of them, and then the next day they picked up 10 more frogs and only 2 of them were marked, they would understand that they hadn't really accounted for all of the frogs in the population yet. And so they would continue to do this until they felt that they were capturing enough marked frogs that they could explain the population based on how many marked frogs they were later capturing. Does that make sense?
And even more specifically, if you collected 10 frogs day one and you marked all of them and then released them, and then the next day you collected 10 more frogs, but only 2 of them were marked, you would assume that the marked population is 20% of the entire population. So from that, you could extrapolate, well, what is 2 frogs 20% of? Well, 2 frogs is 20% of, sorry, 10 frogs is 20% of what?
100, no. 10% of 100, so 20% of 50.
20% of 50. So you would then arrive at, okay, we have a population of 50 frogs. If you then marked all of those frogs, you would now have 18 frogs marked. And so if the next day you collected 3 frogs out of 10 that were marked, then the population of 18 would now represent 30% of the population. So what is 18 30% of, et cetera, et cetera. And as you get more and more frogs, you would get a better idea of what the total population is.
Does anybody have any questions about that? Is that clear?
That's clear.
Great. Okay, and then now that we know how that data was analyzed, can somebody tell me about how many males and females were actually living in the study area, and then how many were just kind of visiting during the study period?
This says that the population density indicated that about a mean of 11 males and 9-ish females resided.
Right.
But only some stayed, so they said that there was a total of 29 females and 20 males recorded within the study period.
That's right. So of the males that lived and females that lived in the study area, they found that the differences between them didn't differ from a 1-to-1 ratio. So about the same numbers of males and females residing in the study area. But then there were some frogs that were observed during the study that weren't technical residents of the study area. So they have the total number of females and males that they took observations from. And it's 29 and 20. So that's population density. Next, I want to talk about territories of males. Can someone explain this figure to me? Perhaps Caleb, Jalen, Claire. Well, Claire, you've done a lot of talking. Luke, I guess, well, anybody, go on.
It's basically outlining the territories of the males that they were studying. So each of the different shapes is the territory that they observed each male defending, and then the numbers next to each of the territories gave information on. So the first number is the number of matings that male participated in. Second number is the number of different females that visited. And then the third number is the total number of female visits. So when that number is higher, it means that then the second number, it means that some females visited that territory multiple times. So she was sampling among different males.
Right. Did any of you guys ask yourself when you're reading this paper why some of the numbers are missing? Like note that there's not a 14 anywhere. There's a few other, I think a 4 is missing.
Yeah, I noticed that.
Okay. Did anyone come up with an idea as to why that might be?
Those are just males that left the study area?
Yeah, so Paul and I were kind of talking about this, and we made the determination that there were 20 total males and that they essentially numbered the males as they recorded them. So they have 1 and then two is somewhere, 2, 3, but then the fourth male was one of those males that didn't defend a territory. So there were 6 males that didn't defend a territory, and they're not numbered because they didn't have a territory. But I thought the numbering was a little confusing, so I wanted to make sure you guys didn't miss out on that.
Because when you think about it also, 1 and 2 and 3 are numbered, but then we're missing 4. But then there's 5 and 6 and 7 and 8 and 9 and 10 and 11 and 12 and 13 is where is 13? 13. And then there's no 14. And then there is no 15. But then there's a 16 and a 17. And then it just stops. So we're missing 4, 14, 15. But if 18, 19, and 20 were frogs that arrived late and as a result couldn't establish territories and then left, those would have been the last 3 frogs in the series of frogs that they had. So it kind of makes sense that the gap in numbers is due to just frogs that didn't establish territories and ultimately left the study.
Yes. Sorry, I keep moving Paul around. It's just I have to see the figure. Okay, so again, kind of on the same theme, how did they define these territories?
Had to do with their calling, correct?
I'm looking for more of the like method of like how they got to these shapes. Did anyone remember what that method is called?
Not off the top of my head.
Okay.
It says the territory is defined as a calling area of one male used exclusively and defended from male intruders. Territory size was calculated using the modified minimum area method. Is that what you're looking for?
That's what I'm looking for. So yes, they had this minimum area method, and that was another thing that I spoke to with Paul about, and I have a little graphic to kind of explain it. You guys can you guys see this picture?
Yeah.
So if you think about all of these squares as the 1 by 1 meter grid that they had for a study area overall, and then you think of each orange dot as a place where they recorded one male, the same male, calling. What they could have done is they could have just drawn one large polygon around all of these dots, but then you get areas in some quadrants that the male was never seen in, here and here. So instead, they use this minimum area method where they attempt to kind of minimize the space where males weren't seen in and draw these kind of more oddly shaped polygons, maybe still.
They're all polygons.
Yeah. So does everyone see that this is a more accurate representation because it minimizes these areas that the frogs were never seen?
You're saying that they basically made a unique shape as opposed to just generalizing each one as a square, for instance, or a rectangle?
Right, because they wanted to only encompass the areas where the frog was actually calling and that were actually included in the territory. And if they would have just drawn these kind of less specific shapes, they would have included quadrants where the frog was never seen.
Didn't they also say that males generally called from the center of their territory? So wouldn't these be closer to the center? Wouldn't these be more internal to their actual territory?
You mean this shape is more central than this shape?
No, so like I'm maybe I'm just misremembering, but I thought the paper said that males tended to call from the center of their territory. So
right.
If each of these points represents a place where a male's calling, wouldn't that be actually in the center of his territory as opposed to the edges?
Yeah, one of the things when you're trying to make territorial assignments is you want to try and not overestimate the size of a territory. As you look at the territories that males have, one of the measures of how effective being territorial, the effectiveness of the territorial behavior is that if you are truly territorial, you should be reducing overlap with other males' territories. Otherwise, you're not really being very effective. And so what they're doing is they're using a conservative method for determining territorial boundaries rather than a more liberal method. So I wouldn't generally use the terms more accurate as much as I would use more accurate or less accurate. I would use the terms more conservative, i.e., the territory estimate is smaller, rather than more liberal, the territory estimate is larger. Does that make sense?
Yeah, that makes sense.
Okay,
Thanks, Paul.
sure.
Okay, so after they were done defining all of these territories, they found that 14 males were defending territories between 1 and 24.5 meters squared. Now let's move on to the next factor. Male calling behavior. How did they calculate male calling behavior?
They added up the total hours of each calling male.
Right, it's pretty simple. This one was fairly easy. And then they found that males called between 5 and 291 hours, and the average was 145.4 hours. I won't make you guys look up those numbers. All right. Male mating success. So how did the males fare? Did they all achieve the same number of matings, or was there variation in mating success? Do you guys remember?
There was variation. I don't remember how many males it was that had more matings. I think it was like 3 males had more matings than the other males because they had like better territories and they competed better for females.
Yeah,
Right.
there's one part that says the 2 most successful males mated 12 times and the others between 0 and 5.
That's what I was looking for. So there were 2 males that were really successful, and the other males kind of didn't do as well.
In the map, it's male number 2 and male number 8 are the 2 really successful males.
Yes. And then
Strikingly, they're not necessarily the 2 males that have the biggest territories. In male 2 has a pretty big territory, but male 8 has a smaller territory than male 3 and male 9, and about the same territory size as male 12, but still got more matings.
yeah, I think that's pretty decently explained with the correlations and the regression, but
Yes.
we'll get there in just a second. So, and then they didn't directly report on reproductive success, but they did say within the results section that mating success was correlated with reproductive success. So the males that were getting more mates were in turn producing more tadpoles. And then what variables explain differences in mating success among males is kind of answered by this table. So can someone who hasn't spoken yet explain to me what's going on this left-hand side of the table?
I think it was this left side is talking about the different variables that affect the mating success for the males, I think.
So do you guys understand what's going on? So they're running a simple correlation test. Does anybody know what this correlation coefficient and p-value is all about?
Does that reference back to the chi-square test that they did, or?
No, it's more like a singular regression line. So the correlation coefficient would be the slope of the line.
Isn't the greater the so like 0.079 and 0.083 they have a higher correlation coefficient, so they're more likely to be correlated to male mating success?
Right, that's right. And they also have this low p-value, which tells you that that is significant statistically. Then
Significantly different from a slope of 0 or correlation coefficient of 0.
and then we have these kind of intermediate correlation coefficients for territory size and the number of days present in a territory, which don't give you a significant p-value, but are noted as being, mildly correlated during the results section. And then you have these very low values for snout vent length and weight, which tell you that those measurements weren't really correlated with male mating success. Does anybody have any questions about this half of the table?
Nope.
Great. Okay. Now can someone kind of walk me through what's going on this side with the multiple regression model? You guys are making this really uncomfy for me. No.
You can tell it's the end of the semester.
Yeah.
I mean, they
There's also
basically
stats, which are hard for most of us to understand.
I get
They
it.
basically found that only calling activity was a significant explanatory variable for male mating success.
Right. So just a little bit of info about how this works from my understanding is that during the multiple regression test, they're testing how each of these variables affects mating success if all of the other variables are held constant. So how does calling activity affect male mating success if these 5 variables are held at a constant value? And then they plug this in kind of a step, the model plugs this in kind of a stepwise fashion so that the variable that explains most of the variation in mating success is kind of produced out first, and then the variable that explains the next most success would be next, so on and so forth. But when they did this, they essentially found that calling activity explained 86% of the variation in male mating success. And the next closest, if you will, variable is this perch height. But again, the results didn't have a statistically significant p-value. And so when the variable no longer explains a significant difference or a significant effect on male mating success, then the model stops producing result columns. So you can see that it stopped here at average perch height because territory size and number of days present, snout vent length, and weight didn't really explain the variation well enough for the model to produce those results.
And the reason that average perch height is not significant in this case is because it's not explaining any unique variation that's not already explained by calling activity. If it was explaining unique variation, then it would have fallen out as a significant predictor as well. But it's basically giving you the same information that calling activity is giving you. And so if perch height is high and that's correlated with with mating success, then those individuals who are also calling up a lot are also calling from high perches. So they're basically telling you the same thing.
Does anyone have any questions about that? I will do my best to answer, but I too am a statistics rookie. No. Okay, well, on to the next slide. Female choosiness. So if you guys remember back to the hypotheses, one of their hypotheses was that because females have this lower potential reproductive rate, they're going to be choosy. Can anybody tell me about some of the evidence in the paper they found that supports this idea that females become choosy?
The fact that they sample multiple males before potentially mating with one, or even between matings, they sample males.
Right. And which males are they most likely to mate with?
The ones that call a lot and have a high perch? Is that what you're looking for?
Yeah, so kind of what I was looking for here, but yes, that is true, are that females visited the territories of males that had the highest mating success most frequently, And this is kind of what you were referring to, Logan, when you said that they were sampling males. So the researchers recorded 11 times where a female kind of sampled a male in his territory, decided he wasn't for her, and left, but only 2 times that a male stopped courtship calls trying to get a female to advance towards him. So they did a chi-square test on this and found a significant difference between that 11 and 2 times rejection number, if you will, which tells you that females are being more choosy with males than males are being with females. Everyone following?
Yes.
Okay. All right. 2 more parts of this data analysis and results. This is opportunity for sexual selection males, and you guys guessed it, I need someone to explain this table to me.
I know at least a couple of you can.
Yeah, I mean, so the mean of male mating success is 3.14, and then that variation of male mating success is 17.36. And so to get the intensity of sexual selection, and that variance is pretty high. So to get the intensity of sexual selection, you have to square the mean and then divide that off by the variance, so that you're basically not, by squaring the mean, you're, Dr. Kwinsky, isn't it so that you like balance out the variables, right?
Well, I would have to go back and reread Wade and Arnold, because I haven't read that paper since graduate school, to figure out why the mean is squared. Basically, it's dividing the variance by a measure of the mean so that you get a measure of variance that is scale dependent. So if the mean is really high, chances are the variance is really high. And so by dividing the variance by the squared mean, you get a variance estimate that is independent of what the mean is. Does that make sense?
Yeah, I think that's what I was thinking of, was scaling.
Yeah.
The,
Yeah, back when you guys were in evolutionary ecology, I gave you the example of, if you're interested in how variable tail length is across a variety of species, you can't just look at, a bunch of elephants, measure their tails, get the average, calculate the variance between, variance within elephants, and then look at a bunch of mouse tails, measure their mean, and calculate the variance among mice, because a mouse tail is really short because a mouse is small, and an elephant tail is really long because it's an elephant. So that the variance in elephant tails would be much bigger than the total length of the mouse's tail. And so the way that you can make those 2 measures of variation comparable to one another is by basically dividing that variance by the mean. And then everything is now on the same scale, variance corrected by mean. And that's also how the coefficient of variation works, which you're probably about to talk about.
Yeah, so Kennedy, I think you did a really good job. Basically, the point here is that, we have this mean, but the reality of the situation is some males were getting a lot more mates than other males. So you have this high variation in male mating success that then contributes to this high intensity for sexual selection. This number would typically be between 0 and 1, and you can see it's 1.76. So that's a pretty high intensity value. Paul and I went over the coefficient of variation and how you calculate it, essentially by taking the square root of this variation. Now I can't find that variation number, dividing it by the mean, multiplying it by 100, and then you come up with 132.6. To me, this coefficient of variation and its magnitude communicates a lot of the same information as this high variance of male mating success number.
It actually convinces or communicates the same amount of information, because if you think about the intensity of sexual selection, it's the variance, which is the standard deviation squared, divided by the mean squared, whereas the coefficient of variation is the standard deviation unsquared divided by the mean unsquared. And so in this case, it's kind of telling you
The same.
very similar information.
Right. So that's the story of sexual selection. High probability there. And the final thing that they did was this timeout measurement. So the way I wanted to talk about this was to show you the equations for the males and females and kind of have you guys tell me what the parts are all about. So can someone explain to me, this is for males, what this 2 times 1.5 hours is all about? Like why 2 and why an hour and a half?
Wasn't an hour and a half the average mating duration of a mating event?
Right, that's right.
And then the 2 is it just they're assuming 2 matings in a 24-hour period? Maybe I don't know what the period is, but it's 2 matings.
Yeah, if you guys look at the paper on 218 at the bottom, it says, because of high egg mortality and small clutch size, a female must produce 8 eggs and a pair must mate twice to obtain 1 hatched tadpole. So this equation takes into account the fact that there has to be 2 matings in order to get a tadpole. So then you have 2 times an hour and a half per mating. And then can someone else explain this 12 times 0.17 hours bit?
The 12 refers to the number of days that between ovipositing and hatching, and then the 0.17 is like how long it took the male to hydrate the eggs.
Right. So the total equation says we got to mate twice. Each one takes an hour and a half, and for 12 days, I have to go and hydrate the babies, the eggs. And so that leads to a total of 5 hours. The female situation is a little bit more complicated. So I will start here at this 8 days. This one might be the hardest one for you guys to remember. Does anyone remember what this was about?
That's how long it takes her to produce the eggs.
Yeah, so again, she needs about 8 eggs in order to produce 1 tadpole, and they used the number of eggs that were average in a clutch times the amount of time a female spent between matings to calculate that essentially she produces 1 egg every day, so she needs 8 days to make 8 eggs. And then we have this 2 times 1.5 again. That again refers to 2 mates and 1.5 hours for each of them, 2 matings, copulations, if you will. Can someone tell me what the 3 hours is about?
For the tadpole transport.
Yes. And then 22 days is for?
Tadpole rearing.
Yes. So going and feeding them, here's transport to bromeliad, and then this is how many days she's going and caring for the tadpoles before they're ready to be on their own. So that led to 30 days and 6 hours, and then they took this difference of the female and male timeout and calculated this difference as 73.5. I had a question about this 366 number. Did anybody figure that out? Why it's 366 and 30 days and 6 hours is more than 366 hours?
Right. So instead of taking 30 by 24, they took 30 by 12 because the frogs are diurnal. Is that how you say it?
Right.
Yeah, that's the term for being active just during the day.
Right.
Okay. Yes. So essentially, like Kennedy said, they multiplied 12 hours times 30 days. instead of doing 24 hours because they wanted to only kind of represent the time that the female was actually active and caring for the babies and producing the eggs. Okay, so that takes care of all of the data and how it was analyzed and what they found. Can somebody just run through some quick conclusions of this paper? I feel like they're pretty straightforward given what we just discussed.
Yeah, just that, I mean, relating back to their hypothesis that timeout was higher for females than males, which means that the male or the female PRR will be lower than, and that means that the females are going to be more limited, they're going to be choosier, and some other results emphasized that they were choosier as well, and then that sexual selection is also being driven by male-male competition.
Right. Yeah, Kennedy hit a lot of them. So yeah, like Kennedy said, the male timeout is less than female timeout, which means that they have a higher reproductive rate. And then kind of relating it back to what Trivers said, the females are this limited sex, so they get to be choosy, and the males are competing with others for access to the females. You get this operational sex ratio that is male biased. And we already talked about the strength of selection being high on males because there's a lot of variance in male mating success. And females are choosing males that have certain attributes, in this case, males that call more frequently. So then sexual selection will push males to tend to develop or engage in calling more frequently. And then finally, the mating system is polygamy. Overall, that's what I categorized it as, but it could probably more accurately be categorized as sequential polygyny and sequential polyandry, with males mating with more females at a higher rate than females mating with more males. Does that make sense? Males were mating with a bunch of females more often than females were mating with a bunch of males, but either way, everyone was mating with more than one other.
Yeah, you'll also see this in the literature sometime as asymmetrical polygamy. So
Yeah.
there's polygamy going on, but the level of polygyny and polyandry are different in this particular system.
So does anyone have anything to add to these conclusions or any questions about them?
Nope.
Cool beans. Yeah, I thought like they're pretty clear once you get through the data and the analysis of that data. So it's kind of a summary. Oop. Well, I almost gave it away, but maybe you guys didn't have time to read that. Did anybody have any ideas for future experiments? I know I had a hard time with this because a lot of the ideas in this paper really line up with the ideas we talk about in class, so it's kind of hard to think of something else to do. But I know all you guys had an idea, so someone tell me their idea. Oh, okay, well. Y'all turned in summaries.
We only have 3 minutes left. Why don't we just cut things off here, and we'll pick up future ideas at the beginning of class on Friday.
Okay.
All right. Does anybody have any questions? All right, that'll give us a couple more minutes to flesh out the future steps, and then we will continue talking about sex allocation on Friday. All right.
Do we need to read any part of chapter 11?
It's chapter 11 on
Altruism.
Altruism. We're not going to get there. So no.
Paul, will you stick around because I have a question or two for you?
Sure, no problem. All right. I'll see the rest of you on Friday.
Bye, everyone. Thanks for coming to my TED Talk.
Thanks.
Later.
Good talk, sis.